So any thoughts on this? But okay, so any thoughts on this particular question? Anyone? Like those who have joined just now? Like I can see that a number of people have joined. You can take a look at this question, and then I will again just like two more questions have been discussed before this. I will quickly go through them and just give my introduction again and explain like what we will be doing in all the weekly sessions. For now, you can take a look at this question and try to answer that. Okay, so let me just give you a explanation here. This question is basically related to a life cycle approach. Now, what is a life cycle approach or what is all those concepts? I'm hoping that, or there may be some of you that may have some idea of it. What happens is that in a life cycle thinking or a life cycle approach, what we do is that we try to make use of all the resources that are available to us and try to do one thing, that there should be as less disposal of waste as possible. So, for example, we have certain material in our home that we are utilizing. After we have utilized it, used it, recycled it, the remaining part of it, it goes into the dump site or a landfill. So what happens is that then another set of people are there who will collect those certain valuables from the dump sites, again take them to the recycling centers, and they will again come into the market. So this concept is also called circular economy concept. I can just show you an example. Wait, I will stop sharing my slide and show you some Google images of what I am trying to explain. So I hope my screen is visible. So, so circular economy concept means that whatever is used or generated in the economy, none of it goes out of that circle, and a particular material is being used for a number of times. Let's see if I have a good quality picture. Yeah, this is a good image. So in here you can see that what happens is the usual supply chain. Let's hide this. A material is manufactured by the industries, then the product is sent to different levels to service provider. After it is used, it is dumped somewhere, then it again comes into the system. Like this circle, you can see this thing is kind of circularity, and it means that nothing is being thrown out, or if at all something is being thrown out of the system, it should be as less as possible. So there should be more of recycling, refurbishing, reusing, these kind of concepts. So we are putting less load on the mining and utilization of various virgin materials. For instance, we have our mobile. Once its lifespan is over, or once we want to buy a new one, there are services from Flipkart and Amazon where we sell these or get them exchanged. So what happens then? It goes through certain vendors, certain units. What they do is that they again recycle it, refurbish it, and bring it again back into the picture. Or at all, if they want to produce a new mobile or just want to discard that, what they will do is that they will get their the rare earth metals or the important elements that are present into the mobile. They will take them out and reuse those particular components. So this is how the concept of circularity works. And now if I come to this question, what it is saying is that a certain material is generated, it is being used, now it is thrown to disposal sites, and from there again it is being recycled and coming into our daily lives. So this means that it is kind of a cradle to cradle model. Why cradle to cradle? The first cradle means in this aspect, for example, if I take example of this mobile phone itself, first cradle will be the place where the minerals and metals they are being mined. So that is the cradle from where the activity is getting started. Now again, after going to that cradle, it goes through a number of processes, then finally it reaches our hand, and then again it is disposed. And if someone is recycling it, then again that raw material which was initially being mined, that instead of being mined, it is getting recycled, and we are avoiding that environmental burden due to the mining activities. So this is a cradle to cradle approach. Do you any of you get any point to share, or do you want me to explain this again? I will go through each of these points so that you can get a better understanding from the examples. First, cradle to grave approach. I will take example of ethanol production. First, we have uh, check whether you can see my screen or not. Okay. I hope my screen is visible now. So first step, sugarcane cultivation. This is the cradle from where the story is beginning. Sugarcane is getting cultivated as the supply chain moves forward after going through various agricultural activities being harvested and all. Then this reaches the industry, let's say sugar industry, where one of the product is the sugar that is generated, and then another is some of the raw waste residues or low economic value residues that can be sugarcane bagasse, for example. Bagasse is the part that is left after all the juice is being extracted from the sugarcane. So that is one of the residues that is generated. Cane bagasse. Yeah. So this is generated, and now, for example, what we do is that, and another important one that is generated is molasses. Although molasses today have quite significant economic value because it is being actively used for ethanol production via fermentative routes. So it will be molasses. Okay, so fine. So now this is the starting of the process. Fine. So the process begins here, sugarcane cultivation. It goes to sugarcane industry where it is further processed through various techniques. Finally, what we get is that one of our main products that is generated, it is sugar. This is our main product that is generated. And along with this, we have some byproducts, which is byproducts or residues, molasses and sugarcane bagasse. Now, if our story ends here, the industry just disposes this sugarcane bagasse to any landfill or somewhere and dumps this molasses into some wastewater treatment plant, which actually doesn't occur. So then this will become a cradle to gate approach. What was the first option? Yeah, this is this option, cradle to gate. Because what happens, the gate of this boundary that you can see, it is a system boundary, and the materials or the units or the processes that are inside it, that is to be considered in this example. So the cradle is sugarcane cultivation and the gate is sugarcane industry. So what is happening outside this, we don't need to get concerned with that. This occurs in terms of cradle to gate approach. Now another one in here is cradle to grave. Now for example, this sugarcane bagasse has been dumped at landside, sorry, not landside, landfill, and the molasses, they are going to wastewater treatment plant. Now what will happen if I take a look at it in terms of cradle to grave? Then I have to go to its grave. Like, where will the molasses end up? They will end up in a wastewater treatment plant, or in some other cases, they can be something else. But for this example, I'm assuming that it goes to a wastewater treatment plant, and sugarcane bagasse, it goes to a landfill. So the grave of this two product will be, one is wastewater treatment plant, and another one is this landfill. So the system boundary will then be expanded. Okay, so this boundary is now expanded. And this molasses will be going forward at WWTP's wastewater treatment plant, where it will be treated, and finally the appropriate or the less organically loaded effluent, it will be discharged to some water body or used for some any other purpose. Similarly, the sugarcane bagasse will go to a landfill. This sugarcane bagasse will go to a landfill. Now this is a cradle to grave approach. Now what will happen in terms of cradle to cradle? In that case, I will remove landfill, I will remove the wastewater treatment plant. Now, since it is a cradle to cradle, it means that it is again coming back as a feedstock into some process. So the molasses will, instead of going to a wastewater treatment plant, it will rather go to a ethanol producing unit or an biorefinery, that we often call it. So this will, instead of going here, it will go to biorefinery, from where I have ethanol production, from where ethanol is getting produced. And instead of just throwing away the sugarcane bagasse, I will use it as a feedstock in those, you must have heard about waste to energy plants, where we often take our agricultural residues or any other good calorific value or heating value material or waste. We burn them and then generate the electricity in the same way we do in coal-fired power plants. So now, instead of dumping the sugarcane bagasse in a landfill, we will take it to a WT's waste to energy plant, from where it will generate electricity. Now in here, electricity will be generated. And then, for example, there is another process in here. Let's, for example, due to some reason, sugarcane bagasse is again using ethanol, maybe whatever reasons. For example, I have to get some fertilizers to the agricultural field. For that, I need a fuel, uh, which we often hear is that today government is pushing for ethanol blending. And for the transportation purpose, the fuel that is being used, it is ethanol. So in that way, if we try to think of it, we will see that the ethanol again will be used in sugarcane cultivation for carrying any fertilizer or some other materials to the agricultural field. So you see that whatever was generated here, it was the cradle. Then instead of getting to a grave, which can be the wastewater treatment plant or landfill, what happened? It became a cradle to cradle. Like whatever residues was generated, ethanol, it was somehow again used for sugarcane cultivation. So it became a circle, cradle to cradle. In the same way, the sugarcane bagasse, which was initially thrown to a landfill, it went to the waste to energy plant. Electricity was generated, and that electricity can again be used in sugar industry or biorefinery for various activities. So this is what a cradle to cradle approach looks like. I hope this point was clear. Please let me know if you have any doubt on that.
For cradle to gate, what where does it go? Sorry, I got a little confused on that one.
Okay, so cradle to gate means like, do you know what is life cycle assessment? Have you come across this word somewhere?
Yeah.
Okay, so fine. So I am assuming that you already have an idea of it, and for the rest of the audience, I will just briefly explain what is life cycle assessment. So life cycle assessment, as the name itself suggests, it is an assessment for any product or material for a certain life cycle of it, and that life cycle can be defined in various ways. In one of those example is this cradle to grave, cradle to gate, and cradle to cradle. So in life cycle assessment, we determine the environmental footprint of a product, of any process or any activity, and for what all processes are to be considered in that this assessment, that is defined by which kind of model it will follow, whether it will be a cradle to grave, cradle to gate, or a cradle to grave cradle approach. So you were talking about cradle to gate. Now, for example, I taking this sugarcane to ethanol production part. So I will remove this sugarcane bagasse from here and will assume that this bagasse is being thrown to some landfill. Fine. So now what will become if I take an example of cradle to gate. Now, for example, I want to blend this ethanol with petroleum and use it for the this vehicular fuel. In that case, what happens is that my cradle will remain the same, that is the sugarcane cultivation. But am I looking at the application of this ethanol? No, I am not looking at the application of this ethanol. If I would have looked into the application of this ethanol, it would have become a cradle to a grave kind of approach, because once the ethanol is combusted, then it can be brought back into as a feedstock, because it will convert into CO2 and various other carbonaceous gases and go away. So that would have been a cradle to grave approach. But what happens is that in as per this life cycle assessment approach, in a system boundary, this is a system boundary. So whatever activities are present inside the system boundary, we are meant to only calculate the environmental footprint of those particular. Uh, just give me a moment. हाँ, चलिए, 9:30 बजे. ठीक है, मैं कॉल करता हूँ तुझे सारा. ओके, ठीक है. हाँ. Okay, so fine. So now what happens is that this is a system boundary, and whatever is there inside the system boundary, whichever processes are there, they are to be considered for calculating the overall environmental footprint of any overall activity or a process. Now this particular system boundary, you can see here this boundary, it represents a cradle to gate approach. Why cradle to gate? That is because the gate is a demarcation that we have set for ourselves, that when I am doing an assessment or any calculations, that gate or that this wall, this will be my gate. I won't be concerned with whatever is taking place outside this gate. I won't be concerned about when ethanol, how is ethanol getting blended with petroleum, how it is being transferred to petrol pumps, how it is performing when it is acting as a fuel. So I have demarcated myself with a certain gate, certain level, beyond which I will not include or consider in my analysis. Maybe this is done to reduce the complications and all. So this barrier or this demarcation, it is called a gate. So anything outside this gate, it is none of my concern. And my concern, as per this example, will be only from cradle, this sugarcane cultivation, to gate, and the gate will act as the output from the biorefinery. So anything that is going outside the gate of a biorefinery, I will not look at it, what is happening with it, what is the environmental impact of different activities that the ethanol is going through. So all those things are outside my gate. So is it a bit clear now?
Yeah. Actually, I'm not able to understand the difference between the cradle to grave and cradle to gate because it appears both are similar.
Yeah, both can be similar. For example, I am taking the sugarcane bagasse out of the picture. No, I will keep the sugarcane bagasse and take this out of the picture. That will make it easy. So you are talking about cradle to grave and cradle to gate, right?
Yeah.
Okay, so fine. So for example, my sugarcane is being cultivated. This is cradle, that part is certain. So once it goes to industry for sugar production, three main streams are there of residues which is generated. One is main product sugarcane and two are residues, that is molasses and sugarcane bagasse. fine, or bagasse, whatever we may call it. So am now particularly discussing about the cradle to grave system. So grave means wherever a certain material ends up at the end of its life. So now I am not going to use this molasses for any economic activity, production of ethanol or something. This product, this molasses, I am going to treat it as a waste and I want to dump it to its grave. Where will the grave of molasses be? Molasses is a very thick, sluddy kind of material. It is having very high organic loading. So I can't just throw the molasses into the environment. This is to be treated first in a wastewater treatment plant, maybe after diluting it, putting it through various aerobic and anaerobic technologies to reduce the organic load of this molasses. Now, once it is dumped into the wastewater treatment plant to further process it, the wastewater treatment plant, that is WWTP, it is the grave of this molasses. This is where the molasses ends, and whatever is getting out of this boundary, out of this wastewater treatment plant, it is the treated effluent. So, in terms of looking at the molasses, the grave of the molasses will be the wastewater treatment plant. Now looking at the sugarcane bagasse or bagasse, usually people use it for various purposes today, but just for an example, I don't have anywhere to put my sugarcane bagasse into or get some bucks out of it, so I'm just going to dump it in a landfill. So where will the grave of sugarcane bagasse will be? Where will it end up? That will be a landfill. So that landfill is the grave of sugarcane bagasse. Now this is a cradle to grave approach. My sugarcane cultivation was the cradle where all the cultivation, harvesting parts, and all those activities took place. Then the sugarcane was taken to industry. The sugar that was generated, it was maybe consumed by the consumers, and that consumption, it will be in this inside the boundary consumption. The sugar was then consumed. So this part will be inside the boundary. So once the sugar is consumed at the end of life, the grave of the sugar will be its consumption. Again, one stream is molasses that was generated. It will die and end up in a wastewater treatment plant, which will act as its grave. Then the sugarcane bagasse, its grave will be the landfill. So this is a cradle to grave approach. Because why cradle to grave? Because nothing is coming out of the system that I can make use of again into the process.
Got it.
Now, taking this particular stuff itself, now it could have become cradle to cradle. Let me see, someone is in the waiting room. Okay, so it could have been cradle to cradle. How? For example, the wastewater that is being treated here, that is the molasses. It is once it is treated, that effluent or that aqueous stream, it is again used for cultivation of sugarcane. This. So what happens is that again, whatever is treated, it is coming back into the system and being reused. Some money or some value is being gained out of this treatment. So this is an example of how it has become cradle to cradle. It started at a cradle, went through different processes, and again ended up at the cradle. And in terms of the landfill, if there would have been a waste to energy treatment plant where we generally combust this sugarcane bagasse, so whatever electricity that would have been generated, let's say it is being utilized for sugar production in sugar industry. Then this is again becoming a cradle to cradle approach. I think it's clear now. Okay. So
Yeah.
moving on to the next question. This will be, yeah, I think it is visible right now. So the question is the activities including the design, manufacture, purchase, or use of material and products to reduce the amount of waste generated or the toxicity caused due to whatever is thrown away at the end of a life cycle. What is this? All this activity or all these concepts are called, or can be clubbed into any particular term. So your options are composting, source reduction, incineration, or all of the above. So if you take a look at this question and try to read it carefully, it particularly specifies that the activities, and which activities, these activities are particularly related to the design, manufacture, purchase of or use of a material or a product. So whatever is being hidden in this particular aspect or these particular processes that can reduce the amount of waste generated or toxicity caused by the product whenever it is thrown away. So what will that concept be related to in one of these options? Any thoughts? You guys can just, anyone can put their thoughts and we can have a discussion on that. This can be taken in different ways. So that is
The
fine.
composting.
Composting. Yeah, composting can be one correct answer. Although we have got a different answer for this question, but yes, composting is also a correct answer for certain particular instances, not for all. So the correct answer for this particular question, strictly speaking, it will be another one.
All of the above.
Not all of the above. Although, like it is kind of that all kind of composting is part of that. Sorry, some type of composting is a part of that answer, but not all the composting can be called as the answer. So let me just give you the hint. It is particularly related to whenever the manufacturer is designing the product or putting it into a supply chain or use or when however the product is being used. The answer lies in this area. It's design, manufacture, and use. Okay. Any thoughts on that? So I will give you one example. Firstly, regarding the composting, like what happens is that one example of composting is these biodegradable plastics that we hear. Although those plastics, strictly speaking, they are not that good, nicely, they can't be degraded that nicely, and often whenever they are composted, we often face various difficulties and nuisances. They, in fact, sometimes degrade the quality of the compost. But taking that assumption that in fact it is a good degradable material, that compost, sorry, not that compost, that plastic bag. So what happens is that while that bag was being designed, special attention was given to design or manufacture it in such a way that once it is being used, once it is thrown away, it can stay in the environment, degrade naturally, and if someone, some composter or any industry who are into composting, they can collect that plastic waste or have that and make a compost out of it. So in this way, composting can be called a correct answer. But for example, if I am eating something, I am eating something at our home, food, or in restaurants, we are eating something, and whatever leftover is there, that is being thrown away, and often it ends up in a composting unit. But we can't call that something that is being taken care in its design, manufacture, or purchase phase. If some activity is present which is particularly paying attention while designing, manufacturing any product, or determining how it is going to be used, that is called, and at the end of it there can be a reduction in the amount of waste generation or the toxicity. So that thing is called source reduction. Why it is called source reduction? Because we can take any product, it has some source where it is generated, it has some mindset from where it is coming. So right at the source, I am thinking that yes, I am going to design my product in such a way that after its life is over, whenever someone is throwing it away, it should not become a nuisance in the environment, and it should, if at all it causes a huge problem, at least if I address that or try to do something about it, the severity of that problem, it can come down drastically. So what I am doing is that I am paying attention right at the source of the problem, that is at its design manufacturing part. So that is why it is called source reduction is the correct answer. Now, when could have composting become the right answer? Composting would have been the right answer if we could have particularly taken the example of that plastic bag that is biodegradable. And now, when incineration could have been a correct answer, it could have been the correct answer is that if we have a supply chain where I am using plastic and it is designed in such a way that once it is being thrown away, it is collected in a proper way. We have a proper system at place that collects all the plastic waste, and that plastic itself, it is having good calorific value. That means once I combust it, a lot of heat will be generated. So if these things are taken care of during the design of that plastic, and then it is being sent to an incineration unit from where we are burning it and we are generating some energy that we can again use in different processes. For that particular instance, it could have been called a source reduction, but strictly most of the time incineration is not that. Incineration is just a handling of the waste. So taking care of reducing the toxicity of waste generation right at the source, that is design, manufacturing, or in fact purchase or any other use of material, addressing that, it becomes the correct answer becomes source reduction, because I am addressing the problem right at the source. Please feel free to add your opinions whenever you think that something is disturbing or you want to add something. Now we have question number 5. It is kind of a true and false question where I will just give you a statement and you have to think that whether it is true or false. Okay, so this is the statement. What do you think about it? In fact, you can try to address this question by taking examples from your daily lives or any microbial activities, something like that. Because decomposition of organic matter, basically microbes, bacteria are at play, and then you can try to relate it with different activities. One good example.
Household waste can be an example of this.
Which waste? Household.
Household.
Okay, so the natural
Mixed
decomposition of
household waste, which is
in
not
what way?
segregated.
Can you just elaborate yourself?
If the waste is not segregated and it's a mixed waste coming out of the household, then
Hmm.
the decomposition of the food waste or any organic waste would be reduced significantly.
Okay, and yeah, that is correct. And what can the possible reasons be that you can think of?
Because the adequate environment for decomposition is not available, which is air and moisture and microbes.
Okay, yeah, that is, you are very close to the answer. So,
And
like if, yeah, someone is there.
yes, I was opting that the heavy metals can also be toxic in nature. So it
Yeah,
might affect the microorganisms that are very useful for the decomposition.
yeah, you are absolutely correct. And the other speaker was, I couldn't notice your name, sorry. So you were also absolutely correct that if our organic waste stream, we are not segregating it and putting it directly for any organic treatment, then its efficiency will reduce significantly. So the main reason is that if my whatever my waste is in India, around what we usually see, the organic content in a municipal solid waste, it is very high. You can see that it is easily above 40% in most of the areas. And this plastic, it is usually, it fluctuates around 14% or somewhere around that, and rest others follow, paper and all other stuff. But metals are also there, about 2% or something like that. Metals are also found there. Now, when I'm putting all that stuff into a digester, let's say I'm trying to generate methane by anaerobically treating that organic matter. Now, what happens is that my whatever my mixture of microbes are already present in the waste, or if I add something externally, the first thing is that these microbes, they have got a certain amount of material in terms of volume or mass that has been provided to them, and they want that mass to be food. For example, I am giving them 1 kg of material to a certain set of microbes, and 1 kg of material, on one hand, it contains completely organic material, and in another case, it contains organic material plus plastic plus metals and all those stuff. So that microbe, that set of or colony of microbe, they will perform more when they will have more food to eat, and their food is primarily the organic matter. Now, if I along with that food, I have 1 kg of bracket where I can put them food, and I am reducing the organic matter and also putting in this metals and plastic and whatever. So first thing I will talk about plastic is that we all know that plastic is very difficult to degrade, so the microbes won't be able to eat it. Yes, with time they can generate some ability, but it is insignificant. Now coming to metals, as our friend now just said that many metals, or at least a few of them, we know that they are seriously toxic to microorganisms.
Hello.
For instance, yes, someone tries to say something. Okay. So yes, so metals. One example is that we have heard our parents and elders say that you should drink water from copper bottles, water bottles. Reason? Because copper has got antimicrobial activity. Another example, silver. So if I take a look at the waste that is generated in our home, we often find various electronics, and this copper is one of the most commonly found material in various wires and all. Although since it is a bit costlier than aluminium, the presence is less, but similar to copper, we have got various other metals which are seriously toxic to microorganisms. So if I talk about the natural decomposition of organic matter, the possibility of it being hampered significantly due to the presence of heavy metals. These heavy metals are particularly more toxic. So yes, the answer is true. Okay, now moving on to the next question. Okay, now this is a case study kind of question. So you are S solid waste and so okay. So you are appointed as a planning engineer for a solid waste management project. And the task that you have in your hand is to determine the most expensive component of the waste handling project. With the knowledge that you have gained through your past experiences, what do you think is the most costly part when you are trying to handle a waste and process it? So I will just repeat my question again, since it is a very long question, it will take a lot of time to write that. So you are a engineer who is given a job to plan the handling of a solid waste mass, and that your objective is, like in any other project, is to reduce the cost as much as possible. So you have to identify like which component of waste handling is the most costliest one, and your options are collection. I will just write down the options: collection, storage, treatment, and separation. So this is a very interesting and important question. So what do you think about it? Out of these four, which can be the most important or most costly affair in a solid waste management project?
So the treatment process.
Okay, treatment can have a significant impact. Like you have to think, but you can take example from any other parts of your life or any other example if you can think of anything. Treatment has a significant impact, but it is not the most costliest one.
I think it would be collection.
Yeah, collection is actually the most important and costly one here, because in fact, if I have a very sophisticated treatment unit which is having state of art facilities, so for that, what I need is that it is situated at some place, and state of art means it is very costly. I can't just build n number of units and everywhere. So I have a certain unit, treatment unit somewhere, and I need to supply it with our waste. And that waste needs to be collected from each household as per Indian conditions, from different households or from different collection places, and the kind of population we have, the kind of traffic we have. It requires a lot of fuel and a lot of infrastructure, this you called manpower and time, trucks, vehicles, and all, to collect all those waste and take it to the different centers. Now, in case if I want to treat my waste in a segregated way, I have my wet waste and my dry waste. Both of them are generated and segregated right at the source. And I want to treat that one, let's say, anaerobically, and the other, let's say, I want to recycle it. So then my collection strategy should be so designed that whatever transportation units or trucks I'm using, it should be suitable enough to collect those two separated fractions of waste properly, so that at the end of the day, due to some reason, they doesn't get mixed up again. So, and another way, another important aspect in waste management is that today itself we were attending one lecture from one of very renowned professor. So they were stressing that the collection route of this during this waste management system, it is very, very crucial. Based on this collection route only, you will understand how much fuel you are getting combusted, how much time it takes to cover all the areas that you want. So at the end of the day, if you take a cumulative look at all the entire impact of this collection, you will find that this is the activity which requires a huge amount of cost. We were also writing a book chapter about it. I think there the collection cost is more than 50% or something like that. It is more than half of the cost of whatever waste is being managed. It goes into collection itself. And if you take a look at some of the Western nations, like in India, most of the places we see that we have a daily collection system. But recently we have been shared this fact by various professors is that in other parts of the this globe, which are especially developed nations, there people don't see daily collection. There can be certain regular gaps can be there. So various nations adopt that they have got separate bins for people. You store the waste inside, and after let's say 2 days, 3 days, 4 days, we will collect it, and then for 2 3 days again there will be no collection. So that is why in India daily collection is there, and it has become one of the most costliest affairs. Now, the next question will be,
So sorry to interrupt you.
yeah, please.
So I wanted to suggest one thing.
Yeah.
Sir, in India, due to the modifications of the vehicles, like for example, the vehicles are modified into EVs for saving the fuel.
For sorry.
For saving the fuel,
Yeah, yeah,
vehicles are modified into electronic vehicles.
yeah.
Most probably in future, the collection vehicles and all also will be converted into the electric vehicles. So there, the fuel will not be used. So
Okay.
is it possible that in future the collection cost will be less or the treatment cost will be more?
I think it is like as of my experience, the first point that I would like to address, like for example, we are having a majorly this electric vehicle driven collection system. So we can't say that the cost will be less or it will be kind of free, because in fact, even if they are electric vehicles, you must have heard that our government is working on building various vehicle charging infrastructures similar to petrol pumps or nearby that. There will be charging stations which will incur or charge us a specific amount for charging our vehicles. And anyways, electricity that you want to charge your vehicle with electricity, and it is not coming for free. So whether you are using electric vehicle or hybrid or petrol, you have to pay some amount, and that amount will vary depending, if I'm talking about the electric vehicles, it vary depending upon the type of electricity that we are being supplied with. It can be like coal fired, the prices will vary. Now there are various studies in fact that suggest that in India, the if you take a look at the electricity mix, I was just going through one of the documents recently. Currently, as of the 2022-23, about 50% of it we already know it comes from coal fired power plants. You can say around about 30% or something like that comes from hydro. And if you take a look at the nuclear power, it is, I think, just 1.2 or 1.3, something like that, not more than 2. So there have been studies which suggest that if we try to shift towards nuclear energy, And nuclear energy also not the conventional ones that we see here, big nuclear power plants are there, not those types. I can't remember the name, but various Western nations, they have the technology that they build small reactors, place it at different places, and then they generate electricity and supply it to various customers. So that makes it more economical because it generates a larger amount of electricity, and technically speaking, it is in fact cheaper than the coal-fired power plants. Why? Because the coal that we burn in our power plants, most of it is being imported from Australia and other places. So that cost is another one that is being added. So going for this electric vehicles, it won't assure that we will have a like the collection cost will become lower than the treatment cost, because the gap as of now it is huge, and it will be interesting to see down the line in maybe 10, 20, 30, 40 years what happens. But as of my knowledge, I think it is a bit unlikely, because if we look at our population from Indian aspect and the kind of lifestyles we are leading, we want daily collection of waste for personal hygiene and various aspects, so it is required. So that is why you are investing much more infrastructure and vehicles and other uh, equipments to achieve this purpose. So as of that, that was first part of the question, and what was the second part?
The second part of the question was that if the means if we are using electrical vehicles mostly,
Hmm.
so the waste generated from the electrical will be more, and the treatment required for the electrical waste will be more costlier.
Yeah,
So
so
which
if I am thinking of
is
it in terms of the end of life treatment of those electric vehicles,
yeah, yes, sir.
that is definitely going to be another challenge. So,
So my question was also that the variation, will it increase or will it decrease, the variation between the treatment cost and the collection cost?
like we need to do studies on that aspect. It is an
Okay.
interesting question, but if you try to take a look with what you just said, like increased cost for disposal cost of those vehicles at the end of their lives. So that also means that this collection infrastructure, it has got vehicles. So those vehicles will also be associated with certain disposal cost. So there is a certain addition of cost as well.
Mm,
So reduction of collection cost, it can be there, but whether it will be lower than the treatment cost, it is something that is doubtful. Because treatment cost, if you collect a lot of vehicle, if you collect a lot of waste, ensure that there is a proper and enough supply of material to the treatment plants, then it is likely to move forward with a lesser cost. If the supply of feedstock becomes less, then the cost of treating any municipal solid waste, it often becomes more. It's that supply demand kind of concept. So it was that.
okay, thank you, sir.
Yeah, welcome. So the next question is, you have to identify the combustible gases that can be released when a waste is getting degraded in a landfill. So just writing here, combustible gases during degradation of waste in landfills. So which can it be? Your option is CO2, let me see, H2O, CH4, and CO. Fairly easy question, I guess. What do you think? A combustible gases.
CH4 methane.
Which one?
Methane, CH4.
Yeah, correct. Methane. It is the combustible gas that is generated in landfill. This is generated due to anaerobic degradation when there is absence of oxygen, and it occurs in landfill or in any other anaerobic treatment that we see in wastewater treatment plants or for sludge treatment also.
Sir, can I ask one question, sir?
Definitely.
Sir, actually, in aerobic condition,
Ji.
there is BOD level is high. In which phase of aerobic condition, in which aerobic phase? It is initial aerobic phase or final aerobic phase. BOD is too high. And what is happen in the final aerobic phase?
Like you're talking to it in terms of the degradation phases that we have in landfill, right?
Yeah, sir.
Okay, so initially what happens is that I have dumped my waste into a landfill, then I lay a
Yeah.
cover on top of it. Fine. So
Okay.
what happens is that when I lay a cover, obviously it will won't be completely anaerobic. There will be a subsequent or considerable amount of oxygen and air that will be trapped into the pores because it is not air proof.
Okay.
Now we are not sucking every air out of it. I'm just covering it. So that is the
Yeah.
reason why we see a initial aerobic phase. And what happens
Hmm.
that at the end of the like once we have a certain amount of biomass, it has degraded. So what happens is
Yeah.
that it becomes inflated. I think if you attend some of the lectures of Professor Dubey, he often shares an image where you can see that the landfill cover it is there, it is inflated like a balloon. So what happens is that sometimes there is a chances that it can leak out of that, or there can be like if someone is uh, like using that gas, landfill gas that we there is a term bioreactor landfill. I think it is a technical term that we often use, where we use that methane that is generated there. We vacuum that methane, take it out, and during that, at the end of life, there is a possibility that certain amount of air can again seep in due to some cracks or some pores that is there in the landfill cover. So that is the reason behind final aerobic stage, because either it can burst, some air can come in, or if someone is putting vacuum, that is also another reason.
Okay. Okay. Okay.
So anyone wants to add anything, please feel free to interrupt me whenever you want. Okay, so next question, I will just dictate it orally because it is very easy. What? Yeah, so it is related to four options, which are the components of municipal solid waste, and which one do you think of these is suitable to prepare a compost? Your options are glass, metal, food waste, and plastic.
Yeah, this is food waste.
Yeah, definitely food waste. So, for example, now just for instance, I will give you a scenario. Food waste is important because it is a this organic source. Now, do you suggest that my food waste should it have chicken leftovers or meat, raw meat, maybe uncooked meat like that in my food waste? Or in fact, sometimes specifically talking bones, human excreta, raw chicken, or any other meat. What do you think? Should we prefer these things in a compost because they are also biodegradable? So how about if they are present in composting feedstock? You can think of it more in general sense. I think you can guess the idea. Like why? Usually, I will just tell you we avoid these. We don't put human excreta into composting unit. Like most commonly speaking, we don't put this chicken, raw chicken meat or any other meat into composting unit or bones. But why do you think what do you think the reason can be behind this?
So for bone, I have an explanation. Bones, because the bones are means it takes a very long time for bones to get degraded.
Yeah,
For
absolutely.
for live example, if we take, still now the fossils of dinosaurs are still available on Earth. It,
Okay, so yeah, it takes a
the
lot of
live,
time to degrade. That is one correct answer. And another thing you can think of the human excreta and this meat or chicken in terms of normal hygiene. You can try to relate it with. Why do we not want to put our chicken, or why do we don't want to see this dog excreta or any other animal excreta in front of our doorsteps near our homes? Or we don't want to let our chicken meat stay uncovered for a long period of time. The reason being because they attract pathogens very quickly. So that is the reason why when I'm preparing a compost, I'm going to apply it on fields. My farmers are going to work with it. So if I put that human excreta, if I put that your chicken waste, this uncooked chicken and all. So it like significantly increases the risk of pathogenic microbes to grow on there, and which is very much discouraged during these composting activities. So that is very important. Now another example I will give you with respect to composting. For example, you have food waste where you have the leftovers that is generated in some hostel, which mostly includes, you can say, puri, chapati, sabji, and all those stuff. And if you take a look at it, I think most of it, uh, if I exclude the non-veggies and paneer and all, it is having considerably, not considerably, but a bit lower nitrogen content. And when I'm preparing a compost, I have to maintain a certain optimum level of C is to N ratio. That is the carbon content divided by the nitrogen content of that feedstock or whatever my initial material is. It should be within an optimized range of about 20 to 25. But I am seeing that okay, there is less nitrogen or less carbon in my raw material or initial feedstock. Then in those cases, what do you suggest we can do to balance them up? Well, like what we can do if nitrogen is less and what we can do if carbon is less.
Dry leaves if it is carbon is less.
Yeah, that is a very good option. Like if carbon is less, we can add some dry leaves. But we have to be very careful while adding it to a composting unit, because if we add it more, those leaves and twigs, they can have more lignin, which can further take a bit more time to degrade. So dry leaves and all the stuff, it is a very good option to add it for composting to balance the ratios. And when I'm talking about this nitrogen, then people, I think most of them often use synthetic sources or any other nitrogen rich streams, because I don't think I can name any commonly used uh, additives that are used to enhance the nitrogen content if it is less or more or less. It's like that. Okay. Now coming on to our next question, the ninth question. It is a bit memory based one, I guess. Yeah. Like this is a memory based question, and I don't think, like, have you been taught about the landfill liner system and all in the class as of now? How is the landfill liner? What is the thickness, permeability?
Yeah, it's taught.
Okay, so the next question I'm typing in here. In here, your role is an engineer to construct a landfill, and you have to prepare a double liner system. Fine. So what do you think will be the recommended depth and permeability of the compacted soil? You have to answer the recommended depth and permeability of the compacted soil. Your options will be 2 feet, and permeability I am denoting it with capital K. It is either less than or equal to 10 raised to the power minus 6 centimeter per second. Option 2, it is instead of 10 to minus 6, it becomes 10 to minus 7. Then in option 3, it becomes 3 feet, and K is less than equal to 6. Unit is same, centimeters per second. And then the final option, depth is same, 3 feet, and K is less than or equal to 10 raised to the power minus 7 centimeters per second.
The second option. The second option is correct.
Okay,
I
second
think.
option means you are saying 2 feet and less than 10 to the minus
Yeah.
second. So then,
Yeah.
okay. I think that might be like in here, the correct answer is for a double liner system, particularly, it should be 3 feet. and the permeability should be less than this 10 to the minus 7 centimeter per second. Option 2, it might be associated with some of the other liner systems in place. It is basically a memory based question. So this, for this particular double liner system, the depth should be 3 feet of the compacted soil, that is what I am speaking, and permeability less than 10 to the power minus 7. Okay, so the next question. Now I will name or write some of the techniques for waste handling, particularly waste to energy type maybe, and you have to identify among the 4 options that you will be provided which can't be clubbed into waste to energy technique. I'm writing which is not a waste to energy approach or technique, whatever you can say. And the options are composting, mass burning, combustion of RFD, all of the above. So RFD is refuse derived fuel. Sorry, it is RDF. Sorry, RDF is refuse derived fuel. So which of these 4 do you think is not a waste to energy approach? These options, I don't think they are correct.
Composting.
Yeah, composting is not a waste to energy approach. Correct answer. Okay, then next question will be, which of the gas that I will show you, which gas produced from landfills can be called renewable energy source? So for this, I won't share any options. You may try to guess the correct answer because we have just gone through this question few slides before. Like which of the gases can be called a renewable energy source?
CH4 methane.
This
Yeah,
is methane.
absolutely correct. So that is a renewable energy source. Now, next option, next question. It is a very definitive type of question, like what is composting? Basically, you have to answer. And for that, we have 3 options. Composting is a natural aerobic decomposition of organic matter in SW is solid waste. And then anaerobic decomposition of OM is organic matter in a closed reactor. And then third option is burning of the organic matter, and 4 is all of the above. So very obvious answer. Which of this is composting? Option A is what is most of them are saying. Absolutely correct. Option A is definitely composting because it is an aerobic process. And let me just add a couple of points. Yes or no, you have to say. Like I have a system, I have organic matter, I have moisture, and if I don't allow the air to flow, I just let it stay there in a heap, will that material end up being a good compost or not? Or let's say I will just modify the question, I will add air and I will remove water. I have got dry organic matter and I have got air. Will composting occur? And a very good environment for microbes to thrive. This is kind of similar to rusting of iron if you can closely make some coincidental similarities between the two. So I don't have water, I have dried organic matter and good amount of microbes and also plenty of air is there. Okay, so in that case, the organic matter won't be able to degrade properly and become a compost. Because for composting, some of the major points that we need to make sure that it is present in our unit is that firstly, there should be moisture, enough moisture present. Then second, of course, there should be organic matter. We shouldn't see more like metals, plastics, and all those stuff. Organic matter. Third is air circulation should be there. Fourth is the temperature of that entire material. It should be within a certain mesophilic range where the microbes act the best and can thrive and convert that organic matter into compost. These are the basic requirements for composting because, for example, I am adding water, air initially and organic matter and I'm just leaving it be. Then what happens that once the composting process begins, the temperature of that entire mass it starts to rise. So if it rises above, I think 40 or 45 degrees centigrade, then what happens after it goes above that range, the performance of my microbial colonies they start to decrease. So that is why what we do is that we mix that compost after regular intervals, so that once it is getting mixed, the heat can also be dissipated, and then we are avoiding generation of any anaerobic condition inside that heat, because there may be some pockets of anaerobic pockets generated inside that entire heap of organic matter. And once we just mix it again, so that heat that was generated was released and temperatures again begin to fall, and so my microbes can thrive there. So that is why regular mixing is very important for composting. Now your next question will be, and again, a true and false type of question, wherein the point is source segregation is the key to developing better segregation spelling is wrong. Segregation is a key to develop a better SWM, that is solid waste management system. True and false. And if true, why? And if false is why.
So the answer is true.
Okay. Reason being, what do you
Uh,
think?
so if the waste, first of all, if the waste is segregated in a proper manner, so the handling of the waste will become very easy. But as now compared to the current situation, the waste is not properly segregated. Even though the information is shared to everyone that the waste should be segregated properly, then to the waste is not segregated properly. So
Definitely.
the management system of the treatment system, management system, collection system is getting more and more complicated day by day. So segregation will be the best option for the SWM system.
Absolutely true. There may be like in our audience various people who are actively working on this area who have much more experience to see what is happening on ground. So if someone like that is there, can you throw some light on what we are seeing in field? Like we are hearing that various cities, various municipalities, they are working on source segregation. In fact, I have also seen in my hometown. Initially, they went for source segregation, then due to some reason, the entire process was stopped. So, is anyone from the audience or anyone who could have noticed like what is happening wrong? Even if my waste is segregated, still it is not my efficiency of my solid waste management system is not how it should be. Even though I am segregating the waste and giving it to whosoever is coming to me to collect those stuff.
So first of all, I would like to point out the initiative taken by all of us. Proper initiatives are not taken. Like for example, if someone is segregating the waste, so the people look at him like as a kachra wala, as something else like that.
Hmm.
So the moral value of that person get degraded, and the person separating the waste doesn't do it. One reason is that, and the second reason is the collection where the waste is collected. The
Yes.
waste collected, the nuisance of the animals and the flies over there.
Okay.
Like animals like dogs and all, they again the separated waste, they again mix up the waste on the roads area and all. So that is the second reason.
Yeah, like you're mostly correct. Like what happens in most of the cases is that, a couple of years back, recently, our team in IIT Kharagpur, we worked on similar concepts across the river Ganges in various cities like Varanasi, Rishikesh, and various other parts, to observe like how was the waste getting collected, how was it handled, and what we saw is that, as you correctly mentioned, like at places where so-called waste segregation was occurring, first thing, if I take a look at those segregated waste in those segregated bins, if you really take a look at it, you will see that it is not really segregated. And yes, the amount of segregation, it can be better than the normal ones, but it's not what's required. So let's say that I have educated my neighbors, have educated the community to segregate their waste in this way, and now they are segregating their waste. The waste collector is coming, they are taking the waste. Then what we saw is that, once they have collected the waste, if a proper processing unit is not there to handle those waste separately, then it makes no sense. That is why at places, I will not reveal the names of those places, but it are those are very famous places. One of them can are like the cities where we surveyed are Varanasi, Rishikesh, then Anup Shahar, Kannauj. Like these were the places that we surveyed. And in some of those places, the segregated waste that was collected, when they reached at the dump site, most often they were again mixed and dumped. So it made no sense in collecting the waste in a segregated way. If you are anyways going to dump it like that in a mixed manner, it's better that you collect it in a mixed manner and dump it. Why to put additional money to segregate them and do it in that way? So that is why, if we want to go for waste segregation, we should also ensure that we are having an infrastructure available that will at the same time process those two kind of waste separately. That is why, I was going through one report a few days back. It was the Swachh Bharat Mission 2.0. So they specifically have given different kinds of this handling of this segregated waste. They are often they require municipal this what is called MRFs, material recycling facilities. So these facilities are also designed based on the degree of segregation. Like if I have a small scale or manual material recycling facility, the first thing is that it should not receive more than this 5 metric tons of waste per day, because that is working on a manual manual manner. The waste is getting sorted, and that is why it is allowed that some sort of some degree of uh, like non-segregated waste can also go there. But then if I'm establishing or constructing a semi-manual or manual this manufacture this material recycling facilities, MRFs, semi-automatic and fully automatic, then semi-automatic, they work at more than 10 to 100 metric tons of waste generation per day. Like this is the capacity of that unit. It should have 10 to 100 metric tons per day of capacity, and to function that economically, it should get a good amount of segregated waste, not a mixed waste. So if at all I am constructing such facilities, semi-automatic or automatic, and I'm not getting segregated waste, then overall my system is bound to run at a loss. No one can prevent that. So that is why it is very crucial that along with source segregation, I am also maintaining a suitable infrastructure at place that can handle those two wastes individually, and not that it gets mixed up at the end and the problem continues. So that was the point in here. Now the next question will be, yeah, you have to say the full forms or guess the full form of life cycle, this LCA that I have already explained before, life cycle assessment, that way you know. And another one is RCRA. So I will give you some options for LCA. You know it is life cycle assessment. I will give you options for RCRA. Your option is Resource Construction and Recovery Act. Next is Resource Conservation and Recovery Act. Then is Resource Conservation and Recycling Act. And the last one, Resource Construction and Reuse Act. Which of these is a correct full form of RCRA?
So the second one.
Sorry, which one?
Second one, resource conservation and recovery act.
Yeah, that's correct. So moving on to the next question, which is again a true and false type. And this is going to be, I guess, the last question in our today's live session. This question is what is life cycle assessment used to determine? Oh, so this is a true and false question. The statement is life cycle assessment is used to determine the environmental footprint of any product. Whether it is true or false. Very simple and easy question. I think that most of you already know the answer because I have already discussed, we have gone through this, that life cycle is the answer is true. Life cycle assessment is used to determine the environmental footprint of any product. It can be a product, it can be any activity, any process. So it's like that, it can be anything. So these were some of the questions that we had in store for today. Since a few of our participants, they have joined late, I will just go through some of the initial 2-3 questions and then lastly I will just again introduce myself to the audience and that's it. So the first question that we discussed was that which of the following was the most favored method for waste management? The options were recycling, waste minimization, disposal and reuse. Among these four options, the most favored one that we should always work at is the waste minimization. We should look at like the waste generated should be as small as possible, and that is why one of the most looked at or one of the most preferred strategies is source reduction. Like one of the this questions was also having the same answer. Let me see. Yeah, here it is, source reduction. Like source reduction means addressing a problem so that less waste or toxicity is generated and addressing that problem right at the designing and manufacturing stage. So that can aid in waste minimization. Then the next question was that greenhouse effect of methane and carbon dioxide, which one, like the comparison between the two. In here, we already know that methane is more potent than greenhouse gas, CO2. It is, I think, about 25 times more stronger or having more potency than GHG. If I talk about N2 on dinitrogen oxide, then it is more than 200 times dangerous than CO2 in terms of global warming potential. Then in question number 4, we had a discussion on different types of uh, models to determine the life cycle footprint of different processes: cradle to grave, cradle to gate, cradle to cradle. Giving an analogy of this particular system, we have a sugarcane cultivation which is acting as a cradle where the sugarcane is being grown. That is my cradle. Now, once the sugarcane is harvested, it is taken to an industry from where the goal of that industry is to make sugar. Now, the sugar is produced. Along with it, we have two side streams of residual masses that is being generated. One is molasses, which is a aqueous stream, slurry kind of stream. Another is the sugarcane bagasse. So now these two materials are generated. I am talking about cradle to grave approach. So I have three products: sugar, sugarcane bagasse, and molasses. The grave of my sugar is where the sugar or the product ends up. It is the consumption phase. This sugar is being consumed. End of discussion. That is the grave. What is the grave for molasses? The molasses are sent to wastewater treatment plants where they are treated. End of discussion. So the grave of my molasses is wastewater treatment plant. We are not going to look into or consider in my assessments or modeling what is happening after wastewater treatment plant. Till wastewater treatment plant I am looking at, my molasses is going to its grave, that is the wastewater treatment plant. Now the sugarcane bagasse, instead of WTE, it is going to a landfill. I am dumping it there. That landfill is acting like a grave to my sugarcane bagasse. So such kind of model, such kind of approach, it is called cradle, the sugarcane bagasse, and grave approach, where the graves are wastewater treatment plant, landfill, and consumption phase. Now, talking about the cradle to gate, for that you can say that, for example, I have a certain this same example, sugar is being produced. Now, what is done with the sugar? People are using it directly for consumption or for any other purpose or whatever. I'm not concerned with that. I just want to know how much energy, how much material, what is the footprint cost just for the production of that sugar. How it is being utilized later on, what is the environmental impact of different use case scenarios of sugar? I am not concerned with that. Just till the production of sugar, that is still the gate of this sugar industry. That is my concern. Similarly, once the molasses is produced, I am not at all concerned like how it is going to be treated in wastewater treatment plant, what will be its impact. Similar for the sugarcane bagasse. So my focus is limited to this sugar industry, sugar cultivation and sugar industry. What is happening after that, I don't want to know. That is not my goal. So that means the gate of my assessment, the gate of my thought process, it is at the sugar industry. So these kind of approaches are called cradle to gate. Cradle is the same sugarcane cultivation, but the gate is what I have decided that I will stay inside this gate, and that gate will be the end of this sugar industry. Now comes cradle to cradle. Cradle to cradle means something is generated at cradle, that is the sugarcane is cultivated there, then it is again going to industry, the sugar is being consumed. So after that, the molasses, they are going to wastewater treatment plant. From there, the treated molasses is used for irrigating the sugarcane fields. Such kind of approach that can cause that comes into cradle to cradle. Why? Because I started at the cradle, my molasses got treated, and they again are sent to the cradle. That is a cultivation. Similarly, in this sugarcane bagasse, they are sent for waste to treatment, waste to energy facilities where it is combusted, energy is generated, electricity is formed. That is again supplied back to the industry. So this kind of thought process, this kind of system, this kind of approach, it is called cradle to cradle, and it also supports the concept of circular economy as well. So these were the questions. I think, yeah, after this, I think most of you have joined. Source reduction I have already discussed. Then this question was related to whether heavy metals, if they are present in a solid waste, organic waste stream, if at all they can impact the decomposition process, which is naturally occurring, then the answer is yes. The presence of heavy metals, they considerably, significantly, and drastically reduce the performance of any biological processing unit. Not any, but most of the biological processing unit. Then that another question was that if you are appointed as a planning engineer and you need to figure out the solid waste handling project for a certain city, which of these four options do you think will consume most of your money? The answer was collection phase, because you have got various like a huge area, huge population to cover. You have to take care of the routing problem, like which routes should your vehicle cover through, how many vehicle you need at each location, for how much time the vehicle should stop, how many people, how what is the manpower that you require for running all these vehicles and other facilities. So all of these, the fuel requirements, they make collection space as the most costliest one, easily above 60% of the entire cost for municipal solid waste handling. It goes into the collection phase. Then, which of these gases that are generated at landfill are combustible? That is methane. Methane is the gas which is combustible, and it also acts as a renewable material if we can uh, maintain or run the landfill as a bioreactor landfill, because the methane will be generated. We can then use it as a fuel. After that, we have compost related question where you had got four options and you had to guess out of these four which one should be used for composting. And the very obvious answer in here was food waste. Then this is a more memory based question, like you have got a double layer liner system in the landfill. What should be what you say, the depth and this permeability. So option D was the correct, 3 feet of thickness and less than 10 to the minus 7 centimeter per second of permeability. In this particular question, you were asked like which of these is not a waste to energy approach. The correct answer in here was composting, because in mass burning you are burning the waste and you can generate some energy. combustion of RDF, refuse derived fuel. That is also another way where what you get is what is refuse derived fuel. You get a material, you get a waste, which is often called as refuse. You convert it, you make it more dense, you compress it, make dense cubes or some shapes out of it. What are they called? Pellets sometimes and all. So those things become dense, energy rich, and again they can be combusted. It is easier to transport those waste also because the volume occupied by such waste, it is also getting reduced. So a certain limited volume of truck, it can carry more amount of fuel. So in this aspect, composting is the only one which is not a waste to energy approach. Now again, this was related to methane, and then composting. Whether composting is a aerobic, anaerobic, or burning of organic matter, which we have already discussed. It is, of course, an aerobic process where the presence of moisture, with the presence of air, microbes, proper temperature, these factors are very important. And nutrients also, because proper amount of nutrients should also be there. Then next question was, source segregation is the key to developing better solid waste management system. True and false kind of question it was, and the obvious answer was yes. It is very important to source segregate the waste, and to achieve that, one of the most primary thing is that firstly, if at all the waste is successfully segregated, we should have available infrastructure to handle those two streams or three streams of waste individually. Secondly, if I have the infrastructure, if I have the collection means to collect two type or three types of waste separately, it is very important to educate our public, to spread awareness, to let them know the importance of segregation of this waste, how important and how it can make your life easier. And this problem is often seen because in various airports and all, big airports in country, all of them have blue bins and green bins. Blue is for dry waste, green is for wet waste. They have those separate bins for collecting the waste, but if you take a look inside it, most of them which are especially outside, you will see that like you can see food waste in place of this dry collection system. Like food waste and all organic matter, they are considered under wet waste, and dry usually means paper, plastic, all those stuff. But if you often keep it open and take a look at it, you will see like yes, it doesn't make any sense whether you keep one bin or two. People are anyways going to mix both of them together. So that is why spreading awareness is very important, because we often don't realize why we are doing that, what the implications can be. So spreading awareness is very important in this aspect. Then this was full form of LCA and RCRA. So LCA is Life Cycle Assessment or Life Cycle Analysis, and RCRA is Resource Conservation and Recovery Act. And these were the questions that we had in store for us today. And if you have from the audience, if anyone has any points to discuss, anything that they would like to add up, yeah, please feel free to share that with everyone. And another thing I would just like to add up, from now onwards, every Monday from 7 to 9 p.m. onwards, this is the scheduled time. In this particular zone, I will be available for conducting these live sessions. Apart from that, I think one or two more TAs will be there, teaching assistants. They have got their individual time slots. I think you have already been informed about that. I think 6 to 8, one of that is running parallelly. So this will be happening every Monday for my case, and you have all welcome to join it. And please share your reviews, please share your experiences, what you are seeing around yourself, because this solid waste management, it is not just any college level or any such kind of course. I believe it is a very uh, important course that should be and is being taught at the primary school levels in various countries in Japan and also various other places. So you must be having ample of experiences, ample of observations. I welcome you all to please put forth your ideas and experiences and understanding on this aspect, so that we can have a rich discussion on this forum. Also, in case you are having any difficulty while going through the courses that are being taught, that will be taught by Professor Dubey in his regular sessions, if you have some doubt, you are always welcome to share that with us on this platform. In case we are also stuck at some place, I will try to go through it, discuss it with suitable people and get back to you with the answer. Thank you all. If you have anything to add, please, the platform is yours.
Hello.
Yes.
I have some general questions actually.
Yeah.
Uh, this is my first time at Swayam platform, and I am actually a working professional. I have done my PhD, done my postdoc. Now I am having a job. Okay,
Okay.
I am doing this as course out of interest only because I want to broaden my horizon actually. So if I don't give the examination part, will I get any kind of certification or participation for my CV, etc.? Or I have to give the examination for the for to get something. Uh,
The last time I attended this, like similar NAPTEL courses, the examination was compulsory, I guess. Just let
okay.
me check. Like when we are selecting this course at that page itself, there is an option for that. Mm.
And again, I want to know if the examination happens, will it be on Sunday or any working day? Because apart from Sunday, it would be impossible for me to
I understand.
join.
Actually, I am not working with that team. I will recommend you to that you can directly email to this NAPTEL support. They will
Okay,
definitely have
okay,
the answers for that.
okay, sure, sure. Again, regarding this course, actually, um,
Yes.
today there are two parallel sessions running on. Uh,
Yeah.
so I was a bit confused which session to join, your sessions and the other one.
Yeah.
Is the same thing is being taught, or the topic is different in both the modules?
Basically, what we have been instructed is that the questions that I just shared with everyone, those should be the same. Apart
Mm-hmm.
from that, if the TA, whosoever is allotted, if he wants or he or she wants to discuss something else, something relevant, that is totally up to them. What is compulsory or what is recommended is those 15 questions that will be same.
Okay, okay.
Yeah.
Again, due to my work schedule, I actually missed my first assignment and the first week course. I am just catching up. I have in the first week course, I have gone through only four lectures. Today or tomorrow, I will finish all the lecture, but I haven't submitted my assignment. Uh, can I still submit the assignment, or the submission time is already over?
I will just take a note and ask whosoever is handling that part. Actually, I am not involved in all those activities, so I won't be able to answer you.
Yeah, my questions are a bit general and not
Yeah,
directly related to the course
I will
actually.
just take a note of that. Yeah. So, your how many days you are delayed on the assignment?
Uh, I have started from yesterday. I have
Yeah.
completed four sessions
Mhm.
in the video in the first week lecture actually.
Okay. And when was the due date for the assignment?
Uh, I'm not sure because there is no written date or something.
Okay, fine. I will
When
just ask the person and we'll get back to you next time. I will recommend, like, if it is available that you can upload it, you can go ahead and do so. I will
okay,
just write your
okay.
name as well.
It's Gautam Sharma.
Thank you.
Okay, sure.
So what is your specialization? You are like much more apt to share your thoughts on this. You have gone through all
Yeah,
these activities.
I have actually the beginning part. I am already a bit familiar because my master's I have in chemistry. Then I have done
Okay.
my PhD in wastewater management,
Okay.
and then my postdoc is related to fluoride removal material science,
Achha.
nanotechnology part. And in our actually master's course, there is a solid waste management system. So the basic I a bit know, but I want to broaden my horizon for the new technology, what is newly coming up, and what the uh, Western countries are now adopting, all those kind of things.
Okay.
So currently, I am involved in Jal Jeevan mission as a state project specialist in water quality
Okay.
in Assam. So I am working in the Jal Jeevan mission. So Swachh Bharat Abhijan is also our department's work also. So solid waste and liquid waste management is also a PhD's part now a bit.
Yeah.
So that's why I have selected this course actually.
Yeah, it is a really privilege for us that we are having you at least in some of our. We hope we can see you again because
Yeah, yeah, sure.
since you already know that I am currently doing my PhD, so I can have some gaps. So please, if at all at some places some gaps are left here, please you can fill in those.
Yeah, sure, sure, sure.
Okay, thank you for being with us. Anyone else who would like to add something? Okay, so just note like if you don't have any questions, like it's not mandatory that you have to stay here for 2 hours. There is no attendance kind of stuff. So if you have some work to do or if you have something you're looking forward to, you can please go ahead. It is not mandatory to stay in this session. Otherwise, anyone who wants to add anything, recommend anything, they are always welcome. Okay, I see some comments. Lumina Ragupati. No, you don't need any extensive knowledge because if you attend these sessions and other sessions that Professor Dubey and others may be conducting, you will get to see that most of these are very generalized questions and you can relate to them. This is not something hardcore. एकदम बिल्कुल मतलब technical type of stuff is not here. So I think it is manageable. It is a very general kind of course. Yeah, it will. I think you can manage that. Anyways, you can try. There is nothing wrong with it. I believe that it's easy and maybe it can help you in your curriculum somewhere. Simple stuff will be there. I think if you attend these classes, attend these assignment questions, just you can. Oh, sorry. Absolutely sorry. I forgot that I have on mute. So I'm saying that yes, it is absolutely fine if you uh, attend these courses, this integrated waste management, solid waste management, because it is not at all any rocket science or hardcore technical kind of stuff with formulas and modeling. It is a very simple and generalized type of course, mostly targeted to kind of spreading awareness, and along with it, someone who is associated with civil engineering and environmental field, they can also get to learn something extra if they want. And I don't think at all it will be a problem with you are in BTech uh, pursuing your civil engineering. It may help you at certain places, maybe a BTech project and all. You can gather some ideas here and there. And if you attend these sessions and others that such sessions, such assignment questions that people are conducting, I think it will be very useful and easy because I don't think you have to go through them again. Whatever we are discussing here, most of the questions I think will be similar to that. And if you want you have any doubts, you want to get it cleared with, or you have any suggestions, or you are not agreeing with any answer, you're always welcome to uh, like debate on this platform because that way, if you discuss it with us, I don't think it won't be any more necessary to just memorize everything. So to answer your question, it is not any hardcore or difficult course. It is very easy, and you are very much encouraged to try it out. There is no harm in that.